Good morning, everybody. My name is Ingrid Milson, and I work for Tenerrdis cluster as an international business development manager. I'm very happy to welcome you to this second webinar about smart grids in Auvergne-Rhône-Alpes, offered by Tenerrdis and Minalogic clusters. I will just remind you what this webinar series is about. It's organized within the scope of a European project called SmartEnergy, which is a COSME project among six clusters actually, with our colleagues in Belgium, in Italy, and in Hungary. Right now, in this month, we have 3 webinar series going on in parallel. One about hydrogen, one about energy communities, and this one about smart grids. The one about smart buildings, organized by the Hungarian cluster, will start later. They have been impacted by the COVID virus. So at the beginning, this was supposed to be a cluster exchange programs. That means that we were going to try to organize trade missions to invite SMEs from the different European countries to come and visit our ecosystems and introduce them to our key stakeholders. Unfortunately, because of this sanitary situation, we were unable to do so, and therefore we have organized this those webinar series to replace the trade missions we had initially planned. So that's the clusters, the 6 clusters who are the partners of the SmartEnergy project. And the program of our series about smart grids, which started last week on the 4th of March, and sorry, not last week, 2 weeks ago already, and which will continue until April the 8th. So you are, of course, invited to follow all the sessions. And as a reminder, each session also includes some B2B meetings. So you have received a mail together with a link to this webinar with the information how to register for those B2B meetings. And I really invite you to do so because, as I mentioned, originally the idea was to come and to meet with you in person and introduce you in person to our stakeholders. This is impossible, but at least with the B2B meetings, you have the opportunity to have short 15 minutes meeting with the people that you choose. So really take this opportunity and register on the B2B platform for that. So the program for today is really dedicated to smart buildings in smart cities. And to introduce this topic, we will start with a presentation by Emmanuel François, who is the president of the Smart Building Alliance for Smart Cities, and who will make a presentation about a reference model. Emmanuel, the floor is yours.
Okay. Good morning, everybody. I'm very happy to share this time with you. I'm Emmanuel François, the founder of the Smart Building Alliance, which has been founded 9 years ago to support all the stakeholders of the buildings and the cities in digital and environmental transition. So I switch. Wait, here, yes. First, why we created a smart building. The origin of our thoughts is that cities and buildings have arrived at limits have reached the limits, and we need to change our models. We need to change our way of living due to current challenges. And in this context, energy is crucial. Energy is crucial, but we need to rethink all our activities and our usage, and this lead to rethink buildings and cities. In this context, digital is very important and is an opportunity. And we are noticing that more and more we are going to a world which is hyper-connected, where every citizen, every buildings, every mobility, every territory, equipment, infrastructure are connected. But not only connected in real time and interacting each other in real time. And that's the most important thing, this qualificative real time. Our vision is to support this digital transition to environmental transition. And therefore, we founded SBA as a think tank and also as do tank. And today, this organization, I would say, which is almost unique in the world for its transversality, groups around 500 members in France. And within these 500 members, already 10% are non-resident in France. So that means our ideas, what we are doing is going abroad our borders. So we group cities, architects, installers, equipment, cities, telecom, IT, financial industry, industrial. So all these players are sitting together to rethink the building and the city of tomorrow. And our scope concerns not only homes, buildings, but only also district and city. And as I said, how everything is interacting together and how we can make rethink a better world by rethinking the building and the cities. To support this transition, we have a strong organization with three vice presidents, one for smart city, one for smart building, one for smart home, and general secretaries, and also management office and a board of directors. And some attendants today are also members of this board of directors, such as Frank Fischer. Our next step for the next years, but it starts this year, is to develop SBA internationally. SBA is a non-profit organization, and we have a unique target, is a common interest. And therefore, we think it can be interesting to exchange with other countries and to set up SBA independent in every country. And then at the end, to create a SBA international, sovereign of every smart buildings, even France, which will group all the thoughts coming from every country and support the framework on which we worked, which could be a universal framework for smart buildings and smart cities. This is our thought. So what are the main works of SBA? SBA, first, we just for recall, we wrote 10 recommendations, smart and green, last year for all the players, all the stakeholders, how to make a smart building, how to make a smart city, and how to start, and which recommendation. So that's it's very simple, but that's what we did, and this is in French and English. But beyond that, the works of and the goals of SBA are dealing with energy efficiency, health, security, comfort, electromobility, and for all these fields, we are dealing with digital device, connectivity, interoperability, data management, cybersecurity, innovative services, and dissemination, how we can train all the people, all the stakeholders to support this mutation, this transition, which I call civilization transition. And for this, we have set up working groups, commission, first working on the reference framework. The most important is ready to service, and we'll talk about it later. And also to work on the digital twin of the building and the cities, the operating system of the smart building and of the smart cities. Also how we can retrofit existing buildings, existing territories by bringing also digital and transversal commissions such as cybersecurity, networks, DC and digital, artificial intelligence, blockchain, prospective, carbon footprint of digital, regulation, because this is also very important that the law support this mutation and adapt itself, and the regulation adapt themselves, user value proposition and change management. So as I told you, we are at the origin of a reference framework which is called ready to service. Why ready to service, R2S? Because we mean that with smart, with the digital, there is a new value to consider in the building and also in the territories. This is a usage value. So beside the real estate value, which is static, which concern lands and buildings, you have a usage value, very dynamic, and which is linked to the ability of the building and the territories to deliver new services around usages. And it means this is a new economy to adapt. This means also we need to rethink the rules, the regulation around these dynamic usages, and how to consider this value and how to evaluate this value. So R2S framework provide more services, concern also optimization of operation and flexibility of usages. I will go very quickly in the description, but the ready to service framework, the most important points of this framework is to consider that now there is a new fluid in the building, beside energy, beside electricity, gas, and water. There is a new fluid which is IP, and we need to organize the convergence of all the data on a unique infrastructure, IP infrastructure. And then what we said also, you have three layers: the infrastructure layers, the equipment layers, and the application layers. And what is very important, that all these layers are independent. That means if you have a solution which deals with equipment, infrastructure, and application, you can remove one of two without to remove everything. This is very important because today it's not always the case. And for this, we describe how these three layers interconnect itself, and we describe at this purpose the APIs, application programming interface, which enable the compatibility and interoperability of all systems all together. And we also describe how we can connect the data, how we have access to the data, and how the data are opening. This ready-to-service framework is now also supported by ready-to-service R2S Connect. We describe, as I said, the APIs. Just for your understanding, because maybe it's not so, it's a little bit abstract. Just take into consideration residential building. Today, in certain case, you have your own internet access. You are contracting to a telecom operator. That's what we respect. But we say now there is a new network, a network of the building, IP network of the building, the digital network of the building. And this is independent of your network. And this network is supporting all the, the application concerning the building and also the residential homes for crucial applications such as energy, water, gas, also security, and why not assisted living. But what we said, this is belonging to the building. So that means you can pool all the consumption of the building in terms of water, in terms of energy, in terms of also collect the data of all the users, and then integrate the building in a smart district, which you cannot do if you have separate housing with separate data and separate operators. That means what you say here, what you see here, there is a blue point on the bottom of the building, which is called BOSS, Building Operating System. This is a new device, a new, let's say, equipment, but it is not really an equipment, a new component of the building, a new component, which where all the data are converging. And this is, I would say, the heart of the building, the smart heart of the building. This building operating system doesn't exist today, or very, very rarely in buildings. But this is what we need now to deploy in every building, everywhere in France and in Europe and in the world, to answer to the current challenges we have, especially in terms of energy. We will not succeed to manage energy at a building level, at a district level, if we have not a convergence of all the data concerning energies at a point, and which is secured and which is managed. So what I'm saying here is quite important and also quite disruptive. But today, as I mentioned, we have already 500 members who are supporting this mutation, and we said, yes, we have to do it. Now let's do it together. So ready to service concerns not only residential buildings, but also commercial buildings and district development. This is, as I said, a reference framework to be applied at every scale. I would say this is a digital trust framework. And of course, it exists, but it can be always performed. And at this occasion, we are working already on a V2, which will be launched this year. And that's the reason why we want to share also today and tomorrow with you, with other countries, in order to perform this framework so that we can be as much as possible efficient and secure. And so that the data, the management of the data becomes more and more secured, and also to ensure the trust, not only for the players, but also for the users. When I say services, this is what why we say they're ready to service, because there are services. And these services exist. Today we have listed several services which are key for the building, key for territories. We started for energy services, and for this reason we have launched last year ready to service for grids. This is then a declination of the ready to service framework, which concerns especially the data concerning energy and how a building inserts itself in a smart grid. Very, very soon we will launch R2S for mobility for the energy part. So to describe how an electrical vehicle can connect itself to a smart building and how we can manage the charging point. But also we are working on R2S for spaces, to optimization of spaces. That means a space in a building has to be mutualized, pooled within all the buildings and also within a district. And the same for safety, and the same for health, the same for assisted living, personal care. And also recently we will work on signage, so signalization, and user and well-being, and so on and so on. So as you can understand, we are not only describing the condition how a building become smart and deliver services, we are also working on these services and how describe all the components to enable these services now and tomorrow. That means to afford resilience for the buildings and for these services in the time. So ready to service for grids. I will just switch very rapidly, but what is important, we have described 3 levels of the building. The first level is to how the building is connected and share data with its environment and how we receive the consumption information. The second one is how a building is reliable. That means how the energy production consumption data are reliable and stick to objectives. And the third one is active buildings. That means how this building is interacting with a smart district, with a smart grid, and enable to have effacement des données. So it's I'm sorry, I'm losing the English word, but how it can adjust its consumption and to the consumption of a district. Recently, as I told you, we will launch ready to service for mobility. This goes in the same way with data management, cybersecurity, quality management system. And what is quite important, we are launching a new concept, which is EV score, electrical vehicle score. That means how a smart building can integrate the electrical vehicle and be able to manage the charging of this vehicle. So just as description, we have A means how this building can adapt and accept vehicle to grid. So that means how we can how the electrical vehicles becomes a real component of the smart grids. But already with B, it's very interesting. So that means how a smart building can monitor systems connected to network and how we can adjust the electrical consumption of the electrical vehicle to the global needs of the building. We are working also, of course, to ready to service for district. I will switch, but in this framework, we are just mince, qu'est-ce qui s'est passé? Sorry. And of course, we are also working on the description of the data, so the building operating system, and which is quite important. And our target is at the end to describe the digital twin with convergence between the static data of the building with the dynamics data of the building, and to have a global overview in real time of the building and the district for all the services. I will just sweep very quickly, but this was also a topic I wanted to highlight because the topic of today is energy, and I have the conviction that we need to go to hybrid networks for every networks, and I would say more hybrid hybrid equipment, hybrid building. So, but let's start with networks. And first, energy. 120 years ago, we decided to have AC with electrification of New York. And today, I say, we need to switch. And we need to have 2 networks, one AC and one DC. Why? Especially why now? Because mobility is in DC. The urban mobility will be in DC. the cities will be more and more electrical, and a part will be in DC. Renewable energies are in DC. Energy storage is in DC. And then there is no reason why we would convert AC to DC and then to AC in most of the case, because all the equipment, electronic equipment we are using, also lighting, is in DC. And if we want to answer to the current challenges in terms of climate, in terms of GES, I think switching to DC is not an utopia. It's just a need, and we need to have it in plan for the next 10 years. And as you see, hybrid AC-DC electrical networks is already a concept merging in the heads of several countries, in the head of several universities, as in Netherlands, the University of Delft. But what I think, and I spoke about it to the European Commission, I think it's time now to have a European plan how we can progressively switch to AC. That means to have a hybrid AC-DC electrical distribution, and especially with digitalization. That means as we are deploying digital in every building and every territories, at the same time, we need to deploy also this DC network. So that's my vision I wanted to share at this occasion, and I hope you will receive it positively. And just to highlight it, my vision is not only energy, but also water. As you know that today there is a huge problem with water, and in the next 10 years, we will have everywhere in Europe problem with water. And as you know that only 10% of the water we are using is for drinking, we need to also to rethink the water networks and to have a hybrid network, one for water we drink and another one for usage water. And the same also for waste. We need to have a local store and a local treatment of some wastes. So I think this is a new way of living, and for this we can provide it just because we are sharing data, and this data we are collecting locally, and then we have a local governance of these hybrid networks we can manage locally for more efficiency. This is a vision I wanted to share with you, and now I would like to answer your question very rapidly. But this vision is just to move to more sustainable territories, with more diversity, more proximity, and more frugality. Thank you.
Thank you, Emmanuel, for your presentation, which went from electrical network to a much broader range of topics, including water and waste. So I see that you are looking at all the aspects of a smart city, not only energy. We had one question in the chat, which is displayed on the screen now. Is the reference architecture documentation available?
Yes.
So maybe if you can send on the chat a link to where people can access this information, I guess on your website probably?
Yes, or yes, on our website, and also on the website for smart building. You can find it also on the website of Certivea. But
if you can write it on the chat later.
Yes, I will do it. I will do it. No problem.
Okay. Another question from Frédéric Lux. Which services are you offering your members?
Our members, the services.
Yeah, the 500 members you mentioned, I guess.
Yes. So the services, because we are offering them to work on this framework, also to participate to the working groups, to also to enrich their experience and their skills. I spoke about regulation, I spoke about blockchain, I spoke about cyber security, I spoke about a lot of carbon footprint, and I think it's as a group together, they work together, they get more skills. So that's, I would say that the first thing, and the second thing, which is very important, is ecosystem, because today we cannot. All the players who are at the smart buildings know that even they are very important and very big, they will not answer, they will not succeed solely, lonely. They need to work with others. And they find this ecosystem at SBA with smart startups, with big concerns, with facility managers, installators, regulation, and so on. So that's, I would say, that's the way, that's the agora where they find the answer to their questions.
Okay. Thank you for your answers. I guess there are no more questions. I give 1 minute for any late question, but otherwise, I thank you again for your presentation.
You're welcome.
And again, presentation will be shared after the end of the whole webinar series to our participants. So please be patient. And now it's time for me. So thank you, Emmanuel.
Please.
It's time for me to introduce Henri Aubara from Schneider Electric. So Schneider Electric is one of our largest stakeholders in our ecosystem. It's very well known internationally. And maybe not everybody knows that Schneider was originally born in Grenoble, where Tenerrdis is located. So I'm very happy to give the floor to Henri if he's around us. Henri, can you turn on your camera? Yes, hello. I give the floor to you. Thank you. Can you test the microphone?
Yes, hello. Can you hear me?
Okay, good. Yeah.
Excellent. That's a great tool. So, Quentin, I don't know if you received my presentation. Otherwise, I will have to share it.
If you can share your screen, please, because I have not your presentation.
I sent it, but I guess it was a bit large because there were some high definition picture. So this is why maybe you didn't receive it.
So, as you wish. Do you prefer that I share my screen, or as you wish?
It's up to you. If you have my presentation, you can share, and then I will need to share my screen because I will enter into a dynamic mode rather than a static slide mode. So
okay,
we can start with the slides and then switch to my screen.
Okay.
Maybe in the meantime, Henri, you can explain us what you do for Schneider?
Yes, of course. So within Schneider, in fact, I'm part of what we call the Schneider Digital Organization, and more specifically within an IoT team dealing with analytics and artificial intelligence. So my domain of responsibility around buildings, whereas of course Schneider is actually making business on many other different segments, including industries and more, but you might know what Schneider is about. So the presentation shall be ready, and I wanted in fact to present and take advantage of the fantastic Emmanuel presentation for the context around building and smart city, because I will drive you to, I would say, what we have done, not only in Grenoble. Grenoble will be the focus of my presentation, but also to give you a taste of the reality of what a smart building can be. So First slide, it is an introductory slide just to give you a taste of the impact of activity around building all along its building life cycle, as we call that. So it started very well in advance during the pre-design stage when there is a building project starting. And then all along its life, the building will impact the environment, consume resources, but also take care of people into the building, because you all have to remember that not only we are spending much of our time indoors, and more specifically nowadays with the COVID, but in normal situation, we still spend 90% of our time into that building. So, whoops, not so quickly, please, Quentin. Can you go back to the previous slide? Yes, thank you. So what we call today within Schneider building of the future is that we have the vision of an all digital and all electrical world, and this will be applied to our building offers and solutions. So this is enabled today thanks to the convergence of and integration, as mentioned many times by Emmanuel, between the IT and OT. So next slide, please, now. What can we think and how can we do that? So we have learned many things today from Emmanuel's presentation about electrification, DCs that's coming up and showing up, but also when buildings are in fact constructed and start the operation phase. So that's where the effort must be sustained to in fact reduce the impact. How can we do that? We do that by managing energy. Of course, that's the premium, I would say, impact of a building consumption. But not only energy, building consume water and generate wastes. But also to go to the building, and that's another dimension of a building, the transportation shall be addressed. And also together with city planner and city transportation organization, we should also think of new way of mobility. So today we will address all of that topics in one single vision, and I guess maybe some of you knows, maybe more of you knows what I will be referring to as what could be a result of a smart building. That means how can we make building efficiency, building environmental performance visible. Please, the next slide. This is one of the ways we chosen for at least our two buildings in Grenoble. We'll see those two buildings later on. On the left side of the slide, you see a kind of a racetrack, as the American told that. So this was the accomplishment of Schneider Technopole building, which is not that far from Tenerrdis location. And what you see is that the building achieved, in fact, a very high level of performance according to this well-known international rating system, which is LEED. What's that meaning around? So not only we make the data of the building that were invisible, not accessible now, but also visible, because we can think, demonstrating, benchmarking, scoring, improving all the building portfolio of the world and rank that building according to a rating system. Again, we choose the LEED approach because to date, these are the only one that allows and provide a scoring function based on data sharing. And this is the story I will be telling you in detail later on. Next slide, please. That's the Technopole building, as you can discover it going, well, when you come to Grenoble by train. you will be able, in fact, to identify it very easily. It's showing its PV facade, which might be quite a strange way to install PV, because PV on the facade are not that much efficient. But still, these two facades, so on the south facade, this is the south facade, and the southwest facade, on the other side, you can imagine maybe that it is not producing that much of energy. Yeah, that you're right. It's more an architect touch, I would say, around the building. But still, these facades generate a little bit of the share of the energy consumed by that building. So, what was the achievement? What was the project about? How we started that? We started to, in fact, because we were the owner of that buildings, Technopole campus is a set of different buildings. We started, in fact, a project from scratch, meaning, in fact, located on this campus, there were demolition ongoing to prepare the field for constructing these two buildings, so the lab part and the office part. The office part is the white PV facade building. And we started and entered into the project by, in fact, selecting an architect, transferring and writing, in fact, our requirement to the design team, and also selecting further on the construction company that would take care of the building part, of course, of that project. And we input into our requirement to have this construction achieving the highest possible level from the USGBC LEED rating system, meaning platinum. So you see, just one sentence, single sentence in the requirement was sufficient, in fact, to bring together all the team members, the project team member, the real project, to, in fact, structure and ask themselves the question at a given time into the project cycle to understand and capture what was essential to reduce the impact of that project, again, in design and construction. Later on, we just hooked that project building achievement with our operation and maintenance solution for buildings. When I say that, I'm including all that you can imagine being part of a Schneider offer for a building: power, building control, monitoring systems, just to name a few. So that we hooked, we closed, how we can see that in the literature, many ways, many publication deals with the energy gap. So what was expected and what is in reality. So we closed that gap thanks to the commissioning process that we set up very in front of, or very in advance of the project design phase, up to the occupancy stage, and still on. So this is key if you want to address and achieve the expected performance and maintain that performance. And today, that performance is made visible thanks to this lead arc platform that you just discovered today. Next slide, please. Oh, yes, a little bit of word about the building. Sorry, can you go back, please? So, because I was a little bit quick to that building. So the office part is a 10,000 square meter. And the objective set in the requirement was to have 47 kilowatt per hour per square meter per annum. That's exactly the achievement that we have today. So that's a brilliant, I would say, achievement. We also contracted with DG, which is the energy provider in Grenoble, a 100% green energy contract. So we are saying that we are buying, in fact, green energy, and the provider delivered to us a 100% green energy to that building. Next slide, please. Second building, not that far. So you can imagine a close map from Grenoble. So I think Tenerrdis is somewhere here. This new building in 10 City, which is occupied since last year, well, depending on the, I would say, rate of occupancy, but still it's in activity. And the Technopole building is here. So you see just right in the middle, you see Tenerrdis, which is amazing. So if you go along the Rue des Martyrs, which is the name of the street, you will discover that building with that particular color on the facade. But this is not what you will, I would say, be astonished with, is when you go, in fact, along the Isère River, which is just here, there is a bike lane here, cycling lane, and you will discover that the architecture of the building is quite amazing. So what is, in fact, on that facade is the internal stairs that, in fact, allow to connect to different floors. On top of those roof of the building, you will discover photovoltaics. So it's fully covered by photovoltaics. Why? Can you just click for the next text to happen, please? Yeah, this 26,000 square meter of building is set to achieve a 37 kilowatt per hour per square meter per annum in energy consumption, all use of energy included. That means here behind the tree, you can't see it, but there is a large restaurant. So we include all use of energy with this target, meaning restaurant, lab, power plug, ventilation, HVAC, lighting, all is included. The target set for that building is not only to have a very high energy efficiency, but also to be a positive energy building. And this was set by design. Today, we are on that path, in fact, to achieve it. And we, of course, need to wait a full year to make the energy balance to demonstrate the achievement of that building. Of course, again, we asked them, well, we were not the owner of that building, but we were part of the project as the sole tenant at the end of the construction. So we set in the requirement as the future tenant, in fact, to have this building achieving a world champion score for the lead. That means above the 100 points, which is, I would say, something very rare around the world. There are 4, maybe 3 only buildings that have achieved going above this 100 scale of points with LEED. Voilà, I think that's close to my slide presentation. Yeah, that's a good point because it's just an introductory slide to what I will be giving to you as a presentation live this time. So just backing to this first Technopole building case, at the moment, in fact, when we were in an occupancy mode, we were preparing that concept of twins, BOS, whatever those meanings can be. And we say, never mind the words or the wording, we will implement what we think is a smart building and what we think is a building operating system. So we started, in fact, to bring together, connected all data, actuator, control system, monitoring systems into one set of, I would say, a middleware that will then allow for sharing. So ingesting data, transforming data, make this data available to any parties interested in that data. So the very first consumer of that data were, in fact, this digital certification way provided by LEED.org. So that was the first third party consuming data and scoring back out of that data the environmental performance of that building. The second one was a European-funded project, Tabele. This Tabele project is about, in fact, demand response, new processes and optimization processes to integrate the building into a DR scale or schema. And we thought at this time that sharing the data and allowing, in fact, applying back optimization criteria from that consumption would be the very second use case that we can imagine around our smart open data building. So now it's time for me to go on the live session. How can I share my screen? Just a hint, please, guys. Quentin, Ingrid, can you help me sharing my screen?
Yes, so Henri, normally you have the possibility to share your screen with the red button, which is just under the window where you can see me. You
I don't see this button, I guess. Oh yeah, I guess it. Okay, fine. Thank you.
Okay.
Let's run for this live session now. So there are a couple of windows open, and we will start from the end of the story. This is what I share with you, in fact, and I hope it will be running. This is a live animated scoring function of what I show you statically on the slides. So the scoring, I hope it will run. So doesn't matter. We can step back into that web page, which is being, in fact, managed by the USGBC and GBCI organization, where you see, in fact, live the scoring summary, which is here attached. And by clicking, in fact, onto that score, you will see this animated plaque that today needs a little bit of time to run. So you will discover some picture of the building, you will discover video on the normal time before the COVID inside that building, and you are able, in fact, to find a summary of the feature of that building, but also to download the scorecard of this building certification. Everything is open. It started by saying, we allow publicly disclosure of the achievement of that building and the details around the certification. Second step, I hope it will be, it's not running. I will be sharing this link for you guys. Maybe it's running better with your computer. I'll do that in a moment. It doesn't show. Yes, it is there. So let's go. Sorry for these inconveniences and the waste of time. Didn't notice that it will require a little bit of bandwidth. Oh, you hear, you get it in the chat section, you get the link. It's a public available link, so sorry about that. Demo effect. Never mind. So how this data is made available to this organization lies here in the Schneider Electric Exchange website. If you go to the develop section, you will discover part of our work, of our teamwork around analytics, meaning that, in fact, you can have access to these components and try those components for free, provided that you input data on the context you want to solve. First level of openness. Second level of openness, we made those components available. And of course, later on, it is for a fee, sorry. Starting for free and then for a fee. If you go back on that level of develop and sharing of information, remember the name is exchange.sc.com, meaning that we bring and invite all third-party organization tech partners to join in this effort, because we know we can't address all the topics and issues of a building or all segments in industry alone. So we need each other to build a new world, and we need each other, in fact, to increment our knowledge and sharing this knowledge. Second aspect, the data sets. So if you click on that datasets, you will discover there are many, many datasets, some for a fee, many for free. And if you go to this digital twin, we reuse the concept word of digital twin, you will have access to that part of the story. And that part of the story is where we share I would say, most of the interesting data sets around all Schneider segments of business. And if you go back only and focus on building, where you see that there is a large amount of data available, you will discover that we are bringing to the community all this data for any type of usage that those third party can imagine. And those data sticked with the live label means that, in fact, we do have a live update data. That means we have fresh data made available to any parties. Going back to our concern and our context, if we just hit this magical word digital twin, maybe with a space it will be better. You will discover 4 sets or 4 data sets. So there is one which is in a draft version, which is using, in fact, one of our 4 components that you just discovered before. That means you can even see and look closer on what the BAM analytic component can provide in terms of energy scoring, ranking, benchmarking. So that's the key of that component. It will help you discover why and when the building consumes energy according to the outside temperature. Again, remember that component is free for use for a limited time, of course. Then, if you go to the digital twin metadata, you will discover that we make available not only the description of the data, but we provide also a PDF enabling you to understand how we organize the data on that particular case of the Technopole building I was just focusing on during my presentation. So you can then imagine having access to the time series data itself, where you will see that the data has been anonymized. That means you can't even imagine what that ID is meaning if you don't have the key for deciphering, in fact, the information coming from the metadata. So going back to the first page of that, you will discover a second one, which is the time series per day. And this is exactly the sharing of data with the, I would say, certification organization lead. And you will discover here that those data are made available completely in an anonymized manner. And that data sharing process enables us to have a performance score back with our operation. That was, I would say, a dig into detail on how open our system and offers and solution can be, and how we, in fact, invite the community to join us in this effort. I will just finish my presentation by showing you maybe something that you might know that was a success story between 2 organizations, major organizations in Grenoble area. So the IoT team, managed by Gilles Chabanis and Maxime Wadrat, project manager, who developed together with ST a new solution for counting people. It's counting people using infrared or thermal energy, I would say, coming from people and all objects, counting people, and they are also now able, in fact, to compute, in fact, the distance in between people. So that's a great achievement. I encourage you to go and visit this webpage. You will see a video describing the process. And by the way, this is the Technopole building, if you just remember. So here's where all this innovation came out, including the very now well-known SF63 medium voltage switchgear. everything has been invented here. Thank you for your attention. Any question?
Thank you, Henri. We are checking the questions, but I don't think there are any for the moment. We leave you 1 minute to ask question if needed. Otherwise, we will go to the next presentation. So, yeah,
I'm sharing in the chat. Excuse me, Ingrid.
Yeah.
I'm just sharing in the chat all the links I was using.
Yeah, that's very good. Thank you, Henri, and welcome, Raphaël. So, Raphaël Meyer is the CEO and co-founder of Lance Energy Storage, which is a very well-known now startup from Grenoble ecosystem. And we are very happy to give the floor to you, Raphaël.
Well, thank you very much indeed for this very kind introduction. So I'm Raphaël Meyer, the CEO of Lance. Today I would like to share with you some ideas on how we can, through the development of new products, of new services with energy storage, with heating and or cooling management inside the building, how we could imagine shaping an efficient and user-centric smart grid at the European scale. And that's the occasion of putting some subjects a bit at the cross-section of new energy production, CO2 reduction, of course, this very serious issue of the buildings retrofit in Europe, and this aspect to be really kept in mind, which is a large consensus, a kind of population acceptance of the change to be done to fulfill the carbon neutrality society that we are all willing to have just a safe future into the coming decades. Just to introduce a bit Lance, we are not that much a startup anymore, a kind of scale up. We use this term, or a small company of 35 people based in Grenoble. We are born in 2016 in Grenoble, and since we have followed different kind of developments, to date we have about 1,000 units running of our products in France and elsewhere. We started this activity, this production in 2018. We've done a Series A fundraising in 2019, and since we have NG new venture in our roundtable, so we are discussing with this very large energy utility. And as a matter of fact, the fact that NG one day was called Gaz de France, invested into a company that usually finishes its presentations by "the future is electric." It clearly shows that the lines are moving regarding the world of energy, and that more and more we're going to have a really a mix of different kind of energies and of different kind of players, just as the parenthesis. And right now, 35 people into this wonderful team, and 2/3 of the team being involved more or less into R&D developments. Before presenting the products of and offers of Lance, I'd like to introduce a bit our landscape. On the left side of the screen, you have a pretty old graph from RTE, Réseau de Transport d'Électricité. But since you have plenty of those equivalent graphs, that shows you on a yearly base, in blue, the production of wind turbines, and in yellow, the production of photovoltaics. And what you see is that we have really an amazing nature as those two curves balance each other all over the year. It means that theoretically, based on this pretty simple facts, theoretically, you could have indeed 100% renewable mix all over the year, actually. even though we know that we consume more energy in Europe during the winter than during the summer, and that of course the photovoltaics produces more during the summer. But again, if you put the wind turbines, you can balance this a bit. I don't want to enter the debate on how we can reach this 100% renewable mix or 100% decarbonized mix, but you know that you have plenty of studies each year that show how we can reach to that. And clearly there are not problems of energy production. I mean, the production is there. The question is definitely how you consume it. And clearly, the seasonal storage is probably not a strong issue in Europe, but the storage on a short-term period, on a daily basis, for instance, or a couple of days, can be clearly the threshold to be overcome in order to go to those models and a majority of renewables. On the right side, you have also a graph pretty interesting from Shell company, which is not exactly the company of normally considered as being a big fan of electricity or renewables, at least from the legacy. It's changing quite strongly, and they've done this study in 2018, the Sky scenario, which is not exactly a consensus, but it's interesting coming from Shell, where they showed that today we are at the global scale at 20% of use of electricity in final use. It means that 80% of the rest is coming from fossil fuels. So clearly the debate is not only on electricity production. Clearly there are a huge part of users which are using fossil fuels right now. But what they show is that in 2017, what they postulate, that in 2017, this part will reach 60%. So majority of the final users covered by electricity. It means that over the coming decades, we're going to have an electrification process that never been so fast in history. Even at the beginning of 20th century, the electrification was not going at that speed. So clearly the question is, what kind of users must be electrified first? And we consider that the EV car actually is not necessarily the main use. And I will come back on this. We have this other graph, which is pretty alarming, actually. That shows that 75% of the European buildings are in a label D or inferior in terms of energetic performance. That's pretty alarming because if we want to reach carbon neutrality, we should be at the label A. So that shows you a bit the scale of the retrofit to be led in the coming decades in Europe to put those dwellings in the right category. And France actually is not that bad in terms of label A. We're actually the number one or number two in Europe. But the problem is not the new buildings. The problem is really the retrofit. And you can probably imagine thousands of billions of euros to be invested into those retrofit operations. And the key aspect will be about the user acceptance. And if we study a bit in terms of CO2 emissions, what's the main actually emitter in Europe? It's not transportation. Actually, it's heating and cooling. And in Europe, actually, it's mainly heating, of course. So clearly, it's a serious issue that we have to pay attention with. Maybe it's a less how to say, sexy subject, if you will, of the energy transition. It's not an ego vector like is a brand new SUV electric or plug-in hybrid, but actually in terms of CO2 weight, it's more urgent to be electrified or to be carbon neutral than transportation. And that's probably why we have more and more countries that are actually getting rid of the gas boiler into the new building. Netherlands were the first country in 2018 to go in that sense. France actually entered this club by 2021, and Germany planned to do this by 2030. Germany right now is clearly the country of the gas boiler, and there is this study of Fraunhofer on the right side, postulating that there need to be 5 to 6 million of dwellings by 2030 to be electrified for the heat generation, in Germany. So probably at this stage, you know my point. We have to electrify the heating, and we have to do it in a way that we create some resilience for the end users. We have this yellow jacket effect that is pretty well known right now, is that if you don't provide the right change, the right transitions, and the possibility of the people to adapt themselves to the change, for instance, of regulation regarding the carbon taxes. And that was, if you remember, the initiation of the yellow jacket process. And you can imagine plenty, actually, of those bad side effects where actually people will prefer to refuse the change or to even deny the change than, of course, following the move. So it's not easy at all, of course not. But it means we have to consider, we have to have in mind different kind of options to adapt to the wide varieties, of course, of those buildings to be retrofitted in Europe. And at Lancet, we have developed a product that, in our mind, can be very, very performing for at least one part of the use cases of the individual dwellings to be retrofitted.
You have only 5 minutes left, Raphael.
Wow. Okay, I will accelerate a bit. Sorry for that. Too long for the introduction. Well, it's an electric heating system, very performing for the heat generation, and where the most innovative part of the product is onto the integration of the battery storage, which is at the bottom part of the radiator, and the micro inverter of 500 watts. So it means that it's a heating system and it's a storage system with exactly the same features than any centralized domestic storage like the Sonnen, like the Tesla Powerwall. The thing is that having it inside the same product, of course, you will reduce the cost, the total cost of ownership regarding the features that you can deploy. This product can be, of course, in retrofit of an existing electric system, almost plug and play. You have the electric installation in place. It takes a couple of minutes to be installed. So very, very simple. But even for new buildings, for instance, it's of course much less expensive to use an electric installation than a fluid network or floor heating, which is of course for a new building much more expensive. What we imagine with this product is that kind of configuration. So it's not only the Lancet Capella, our heating system alone. It's infrastructure. It's a complete solution with different of those systems, with a link with the smart meter that we have been working since 2018 directly with Tenerrdis, and of course this PV photovoltaics installation onto the rooftop or in the neighborhood. And imagining the same single solution in self-consumption with as much as possible a local production and a local consumption through the storage capacity of our devices in a view of having it running efficiently as much as possible to reduce the heating bill, first thing, so create more resiliency for the end users, to reduce the carbon emissions, and to open new kind of services like grid services, demand response, fast containment reserve. I will come back on that. We have, of course, developed the full package of application. You have the front-end part with the end-user app, but you have also a back-end part which is dealing with model predictive control on different aspects. And the idea is to have the opportunity of treating different layers of constraints, some constraints coming directly from the house, from the end user, in order to fulfill the level of comfort, for instance. But some constraints can be completely external to the dwellings, like the constraints from the grid, like the weather forecast, the availability of renewables in the coming hours or days, the CO2 emissions, and why not into a near future, some constraints coming from, for instance, a community of an energy community with other sources of production and of consumption. The main part at day one is to be very efficient regarding the heating generation, which is, as we said at the beginning, a main source of CO2 emissions and of the heating bill at the end of the day. But that makes also a system that can be adapted over the years to the change of regulation and to more and more complexity, and that's into the end one part of the smart grid. One thing to have in mind regarding what's interesting into the Lancet approach of storage, but of course you can duplicate to other kind of uses, is the fact that normally a traditional system of storage, you have of course the battery pack by itself, but you have also different parts around which we call the balance of plant. And basically a battery by itself, it's a DC, it's low voltage, you can do anything with that. You have to use an inverter to control temperature, to make an energy and battery management system, etc., etc. That costs quite a lot. Actually, that can be up to 50% of the total cost of storage. And that's even more considering a behind the meter approach, like Lancet is. If you embed directly the battery into the final use, of course, you will reduce those part of those associated costs with the storage. And typically, you can find the same kind of advantages with the electric vehicle to grid approach, and that can be interesting to reduce the levelized cost of the storage. And clearly, one advantages of the Lancet approach. One other advantage of this approach, is the fact that considering rather small batteries, we can consider different kind of sources to imagine a second life of batteries quite easily. And as an example, we are working with the largest fleet of e-bikes in rental services around Paris, Véligo Location. It's 20,000 bikes. And Lancet is collecting the batteries after their first life into the bike. And after some tests, we select the best of them to find a second life, but without remanufacturing them into a stationary use. And that's also, of course, a way and an interesting contribution that we can provide as stationary storage solutions to do the circular approaches that are interesting. And of course, part of the solution to the issues that, of course, battery can have, like many renewables, which are, of course, the raw materials consumptions and all those rare materials that we have to use for the moment.
Sorry, Raphael, can you wrap up, please?
Yes, that's my final slide, and then I finished. Sorry for that. Clearly, what we want to participate at and looking for some partners to collaborate with is imagining the step further and where we can shape, we can go above that the single house or the single flat, and go onto a larger scale, and like for instance a group of dwellings, a group of buildings in a collective self-consumption configuration, for instance, or an energy community, and imagining that we can create some additional resilience and additional value to the local production of electricity with more sources and more possibilities of consumption on site, and how it can be both profitable, scalable, and carbon neutral. And clearly, if you, dear audience, have some interest in joining our conversation, you're most welcome. Thanks a lot. I was a bit too long. Sorry for that. Don't know if you have some questions.
Thank you, Raphael. There was indeed one question in the chat, so we will show it now. How geographically specific is the situation? I think it was referring to the RTE data, which showed the wind and the solar productions. So can you comment on that?
Yeah, correct. And dear Frédéric, a very, very good question. That's indeed a graph for France, where indeed we have the widest sea littoral in Europe. So a very high potential for offshore wind turbines, etc. So of course, it's not necessarily the case for all the European countries, but clearly, and I cannot elaborate too much, but imagining to reinforce the different interconnections of the grid at high tension, and imagining that we can increase those possibilities of exchanges country by country, and profiting from the geographical zones where you have at the moment the most renewable potentials, of course that can help. And we will probably always need a part of let's say conventional electricity production as a kind of backup. But very probably this part, imagining a very resilient with massive demand response mechanisms, and again a high end user acceptance, and that's probably something very central actually. We can imagine that those traditional part is really going down into the future, and I think we will talk about hydrogen a bit later. Yes. Hydrogen clearly can be probably one part of those long-term, not necessarily seasonal, but longer than the batteries. And there are probably some compatibilities between the battery storage and hydrogen storage.
Thank you. You're doing my job. You're introducing the next speaker. It's incredible. Sorry, we have just another question for you from Charlotte. What is the capacity of the battery?
Yeah, it's rather small. It's 800 watt-hour of storage per unit. So then you have to imagine 5, 6, 7 different systems. So a couple of kilowatt-hour of storage. That's equivalent to what you get with the standard Sonnen power pack, which is the world leader right now. So clearly it's not sufficient to cover, let's say, the entire night with a solar production during the day. But what we are targeting is not an off-grid house, or is not a completely autonomous house the 100% of the year. We clearly think that it's not useful actually for Europe. We have probably the most performing electric grid worldwide, and this grid can again be the occasion of accessing to very broad production sources with renewables. And so it doesn't mean we don't need actually that much of storage, and we can probably even think that it's already too much actually, because again, if you can imagine some not necessarily too large, but groups of buildings within the same self-consumption configuration, with a bit of tertiary, a bit of houses, a bit of other kind of uses like EV, etc., etc. So complementary uses, if you will naturally increase the possibility of self-consumption, and increase as well your level of self-production. So the needs that you cover with renewables, without too much storage. Again, the goal is to be as cost effective as possible and as light as possible in terms of hardware investment.
Thank you, Raphael. We need to stop here. Thanks a lot. Remember, there are B2B sessions if you are available later in the morning. So thank you. I will now give the floor to another startup called Sylphen, and to Jonathan Morier, a business developer for Sylphen. Are you with us, Jonathan? Yes, he's coming. Your microphone. Yes, perfect.
Yes, I am here.
Thank you. I leave you the floor. Thanks.
Thank you very much. Yes, thank you all. Great information so far. Thank you very much, Raphael, for the wonderful transition to hydrogen energy storage as well. And also very interesting to hear all the new developments that have been happening in the building industry. A little bit of background about myself. I'm French and Canadian, and was working on improving energy efficiency in buildings in Toronto before coming to Sylphen. So it's great to see all the progress that has happened since then. So a little about the presentation today. I'm going to talk specifically about hydrogen energy storage and how it is integrated in smart buildings and how it can provide services to smart grids. At Sylphen, we are looking at this solution in order to provide benefits at the local energy production for the building level. So there are several aims that we have. First is a security of supply, so that the buildings are self-sufficient as much as possible, not completely cut off from the grid, but that can be an option. There is, of course, the objective of reducing the energy bills and CO2 emissions, and overall improving the energy efficiency and reducing the carbon footprint of the building. We've talked about buildings a lot. As a reminder, in Europe, they consume about 40% of the total energy consumption. They're responsible for 36% of greenhouse gas emissions. And so at CIDFEN, we're trying to improve those numbers by making buildings more responsible for their own energy, whether that is on the consumption side or on the production side, so that they become more autonomous, and as well supporting the energy transition, which I'm going to talk about the flexibility that energy storage provides for smart grids, for example. At the core of CIDFEN is our main product, which we call the SmartEnergy Hub. I think I can use this. The SmartEnergy Hub, which we place next to buildings. So you have end users that represents the buildings on the left, which have energy needs with regards to electricity, heating, cooling, and mobility. This is a diagram of just the energy flows that can happen. And in most cases, we're working with a site that has some aspect of renewable energy production, usually in the case of solar panels, but it could be wind turbines, it could be hydroelectricity. And all the energy that's produced will go and feed directly into the building, and any surplus would be fed into the SmartEnergy Hub. The SmartEnergy Hub is made up of three main components. There is a lithium-ion battery, several modules of it. One RSOC, I'll talk about it in the next slide, which is an energy processor. That's the heart of the module and then we have storage, hydrogen storage tanks. We still have the link with the traditional grids in order for backup, but try to use them as little as possible. So as I mentioned, the heart of the SmartEnergy Hub is this reversible solid oxide cell. And for those who don't know, it is basically a 2-in-1 electrolyzer and fuel cell. So those are two different modes. And whenever the hub is in electrolyzer mode, it will absorb the surplus electricity that is being produced and convert that into the production of hydrogen. And in the other way, whenever it is in fuel cell mode, we have the consumption of that hydrogen that has been produced and that is being converted into electricity and heat. And the idea is to provide that energy back to the building. In a nutshell, in a diagram, you have a building which has some source of renewable energy production. The solar panels will provide much of the electricity for the building, and whatever is not consumed right away will go in this SmartEnergy Hub, which is made up of the batteries we represented in blue, and then that energy processor in green. That's whenever during the day, whenever there is surplus and whenever there is not enough energy, that SmartEnergy Hub will give back that energy in the form of electricity and heat. One of the particularities of our technology is that whenever the stocks of hydrogen are completely depleted, we always have the possibility of running our SmartEnergy Hub as a fuel cell and cogeneration using natural gas. If we can use biogas, that's even better because we obviously reduce the emissions. But the point here is that we are able to increase flexibility whenever there is not enough solar production, for example, to produce enough hydrogen. This slide just shows the various specifications in terms of power and storage capacity. So on the battery side, we use lithium-ion batteries in 50 kilowatt-hour modules, and our solution is completely modular. We can put one module just like we can put 5, 10, etc. It's just customizable based on the site. On the hydrogen side, the electrolyzer that we use, so the 2-in-1 electrolyzer and fuel cell, whenever it's in electrolyzer mode, it can absorb up to 440 kilowatt per module. and that will produce 800 grams of hydrogen per hour. And whenever it's in fuel cell mode, it will deliver to the building 6 kilowatt per module of electrical power and 4 kilowatts of thermal power. So again, we're a multi-energy solution that providing electricity, heat, and hydrogen as well, if we're going to explore the hydrogen mobility at a later time, and we're starting to on some projects. This is what it looks like. We have two zones. One zone is the active zone, which comprises of the hardware and the software that's usually installed in boiler rooms within the actual building. And then we have the storage of the hydrogen, which looks like these B50 bottles within racks. And that's, again, completely customizable. That sits in the outside of the building for security purposes. We're targeting all types of buildings. Today, our product offering is really focused on buildings that are 1,000 to 10,000 square meters, whether they're existing buildings or new buildings. Given the nature of our innovative solution, most of our projects are new buildings, but there is definitely the possibility to work on existing buildings. There just needs to be enough space to install our solution, which can be a few square meters within a boiler room. We are working at the same time on a new line of product, which will be 10 times more powerful. So we're looking at 400 kilowatts of absorption in electrolyzer mode and delivering 50 kilowatt of in fuel cell. And that's more geared towards bigger campuses such as universities, hospitals, industrial parks, etc. A quick overview. Sylphen is a startup that started in Grenoble in 2015. Today, there's about 18 or 19 of us. These are the three co-founders on the right. And we're working on several projects. Just a quick three of them. One of them is where we are located, and two others are in Italy, one in Turin and one in Procida, which is a small island off the coast of Naples. I'll talk a little bit more about that one. And at the same time, we have started our commercial orders. So we have we're equipping one residential tower in downtown Monaco. That's the Tour Carmela. And then we're working with a distributor, a smart grid distributor and energy producer in the Hauts-de-France region in northern France. I'll talk a little bit more about that. So with regards to smart buildings, smart energy hub, and smart grids, clearly our solution is geared towards providing more flexibility to smart buildings. Obviously, smart buildings will be able to reduce the energy consumption through load management and through the various services that we saw before, mostly dealing with data. We are, but that's really dealing with the consumption side. Sylphen developed a solution that is geared towards the consumption and the production side. So that is to address the intermittency of the renewable energy sources. So we have a better integration of those, as the traditional grids were not designed to have the installation of such distributed sources. So it's complicated for the grids to adapt. But by making buildings more autonomous, we are a better solution. The Sylphen solution is better able to stabilize the grid without having those sudden influxes of production whenever the sun is shining brightly or the wind is blowing. There is also the possibility to offer production to give back to the grid whenever there is a tense situation and high demand and low supply. So the fuel cell mode goes to the building, but it can easily it can be re-injected to the grid. So that's a possibility. And through our solution, we're also addressing some of the mobility questions that are arising more and more on the electric side, but as well on the hydrogen. whenever we're working on projects that, of course, want to integrate charging stations, but then the question is, when do you charge, at what time? And so with this solution, we are able to decide whenever, based on the piloting strategies, what is the best outcome for the client sites. We're, of course, very driven by data, smart meters that are everywhere in the SmartEnergy hub. And we have forecasting devices to predict when is the best time to be able to switch from electrolyzer to fuel cell mode. So that is what we're working on at the moment. And my last slide is to talk about just several options for smart grids in general and the types of interactions based on two projects that we're currently working on. We have one example in our GIF project, so which is GIF stands for Geographical Islands Flexibility. So as I mentioned, it's a small island off Naples where they're limited with the production of energy and the distribution. It goes through submarine cables. But they're trying to be more autonomous. And this is where we're installing our solution and providing services to the municipality. It's being installed next to the city hall, and it's going to provide power to city hall and surrounding buildings. But at the same time, the flexibility, whenever it is not needed, could be offered to the grid of that island in itself. So we have a self-sustaining energy community that isn't drawing too much on the national grid, and at the same time, it can provide services whenever the owner decides to. On the other hand, we have another example with this the CKA project, which is an energy syndicate in northern France that is at the same time a distributor, but also a producer of renewable energy. And it's a specific case where they have more installed production through the wind power than the consumption that they deliver to. So they have moments during, that's the installed, but also they have actual moments during the year where there is overproduction and not enough consumption. So they have, we signed a contract to install one of our SmartEnergy hubs on their building so that they're able to use through their energy management system to use the flexibility of storing that excess production whenever there is one, and then to re-inject it back into the grid whenever they need it. So this is more the opposite end, where you have the distributor that is completely, has full control over our solution and uses it more as a storage solution rather than investing in expensive batteries or that need to be installed on transformers. What we're going to see in the future is likely scenarios in between, where we have two-way information exchange systems between the various smart buildings and the grid operators. And that is going to be usually in a way where the owners of those storage solutions will be incentivized to provide flexibility to the grid. And when I say incentivize, obviously we think about financial implications, but there is also carbon implications. It's not just purchasing when the prices are high and selling purchasing when the prices are low and selling when they're high. It's also the carbon content of the grid. Some of our customers are very environmentally driven and are using our solution to really reduce their carbon footprint. So they want to be able to use electricity from the grid when it's very decarbonized, but whenever it is around times of peak demand, and especially when we're importing electricity from neighboring countries that have a higher carbon content, then that's the time of day when they want to be able to tap into their local energy storage that they have, which would have been produced through renewable energy production. So that's how our solution can interact with smart buildings and provide services to smart grid operators. We are looking for partners as well to find scenarios in different areas. We're focusing on Italy, Spain, Germany, Belgium, and the UK. So looking for partners, whether to set up projects or potential clients, we'd be happy to have further discussions if you have any questions.
Thank you, Jonathan. Great presentation. You had a question in the chat, but we are running really short and running behind our schedule, actually. So maybe you can answer the question in the chat, or maybe
Sure.
schedule side meetings if needed. We had planned originally a break. We will maybe give you a 5-minute break before the next presentation by Lisa Scanu from ProBias about artificial intelligence for building energy optimization. So that won't be a 15-minute break, please. Let's meet at 10:50 with to hear about ProBias from Lisa. Thank you. Welcome back. I hope you didn't go too far and you are back with us. Can we check if Lisa is with us as well? Yes, she is.
Do you hear me?
Yes, I hear you. Hello, Lisa. So I just give 1 minute for latecomers to get back to their PC and to our webinar. And I give you the floor to talk about artificial intelligence for buildings energy optimization. Thank you, Lisa, from ProBias. The floor is yours.
Thank you. Good morning, everyone. So I will be talking about artificial intelligence for buildings energy optimization. First, I will briefly introduce ProBias. So we are a company specialized in data science and artificial intelligence. We are a spin-off of INRIA and Tenerrdis. We were created in 2003 and acquired by Groupe La Poste in 2016. We are currently 57 employees, mainly engineers and PhDs, and mainly in Grenoble, but we also have an agency in Paris. Our expertise is based in 4 different areas of expertise. The first one is computer vision and sensor fusion, which is mainly used in automotive industry and self-driving cars. We have also an expertise in conventional machine learning, which can be applied in many different areas, such as bank, energy, industry, etc. We have a team expert in natural language processing, which is working amongst other in chatbots. And finally, we have a team we are specialized in operational research and combinatorial optimization, which mainly intervenes in logistics and supply chain. But today, I will be talking about Bâtissance, which is a product to optimize the energy consumption of building, and which is based on the 4 area expertise of before. Bâtissance is a tool to automatically model the building, taking into account the weather forecast in order to optimize the heating and cooling of the building. It goes until the remotely control of the energy equipment. Before its commercialization in 2013, we worked 3 years of internal research and development on this product. We have 2 patents, one on the automatic learning of the model and one on the forecast of external gains. And it received several labels and awards, such as the label Energized by Tenerrdis and more recently the Solar Impulse Efficient Solution label. The main competitive advantage of our solutions is that it is a non-intrusive solution adapted to existing buildings. It can, of course, take into account the external gains, but more importantly, it can automatically control the energy equipments in order to increase the occupant comfort and decrease the energy consumption. Currently, the solution is mainly used for the building itself. The main need from the clients we receive is either to minimize the amount of energy required or to minimize the financial cost of energy consumption. But I strongly believe that a big advantage of our solutions is that we can act on the definition of a cost function in order to take into account many different phenomena. And it can be a huge asset for a smart grid in order we can integrate power capping constraints or integration of storage in order to optimize the auto consumption, for example. We can also take into account several specificities and specificities of the energy market in order to add some revenues for the clients. So it is really easy in this product to change this cost function and to make the building an asset. How it works? The first step will be to model and calibrate our model. So we will divide the building into different thermal zones, and for each of these zones, we will apply a simplified model, which is an analogy of electric circuit. And each of these zones will be equipped with sensors. It's really a simple sensors such as indoor temperature or energy consumption sensors. For the first month, the only thing will be is collecting data. After 1 month, we have enough data to learn the parameters of our model. And then we can go to the energy management part. So this is the second step. Our client will only give us information about its occupancy agenda. Then we will still have our sensors on site. We will continue to collect data. And if we want to introduce in our objective functions some information about financial energy contracts or energy market, we will need to have the information about that. All this information will go first into the thermal behavior forecast, which we just calibrated. And then we also have another brick, which is called weather forecast. In this brick, we won't do the weather forecast itself, but we will collect it. And then we will kind of locate it on this building by a second learning phase, where we adapt the weather forecasts to a building thanks to exterior temperature and the thermal behavior of the building. When we have calibrated everything, we are able to compute the optimal hours to relaunch the heating systems and to control the equipments. Of course, our solution is aimed to be autonomous, but we couldn't install sensors on buildings and not giving our clients some way to visualize the data we were collecting. So we developed a simple data visualizations web application where we can find the different data we collect on site, so indoor temperature, exterior temperature, power, heating power or cooling power, the agenda and the presence if it was. Then we also have different informations about different alerts or indicators to give a quick display of the state of the building. Then I will just give two quick illustrations of some results we got with this product. The first one is we are historic clients, the city of Cessines-Parise, which is a small city around Grenoble, but which had since 2005 already high objectives in energy savings and CO2 emissions. But they didn't have a lot of financial and human resources, so they need to pursue the approach and increase the gains without heavy investments. For us, it was easy in the way that the users and habitants were made aware and the city engagement was really high. But at the opposite, the problem was that there were old buildings with no instrumentation at all, and even the occupation agenda of buildings was partially known. But we first installed our solutions on two buildings, a sport hall and a school. For the first year, we had a very high return on investment because we had like 40% of energy savings for the sport hall. But those are the results 4 years later because solutions allowed to identify several problems we could have been replaced and corrected. And on the long term, so we had like around 15 to 30% of energy savings each year. And now we have 6 buildings of this city equipped with our solutions. And for none of these buildings, we are under 10% of energy savings each year. Then the other example I like to give is the one of the Wupa building. The Wupa building is very different from the buildings which were equipped in Cessines-Parise because it's a really recent building. It was built in 2013, if I'm not mistaken. And it was conceived and occupied by building thermal engineers. And the objective of this building was to be energy positive building. But the problem was that they had installed an active slab, which has a lot of inertia, and the building was equipped with a lot of windows, so it was very sensitive to solar gains. And the energy manager on site didn't succeed to balance these two aspects. For us, it was really easy to install a solution because the building was already oven-mounted. We didn't add to any sensors because everything was already here. But we were really skeptic on the profit we could make because we were used to old buildings. And still, on the first year of installation, we reached 40% of savings on the energy bill. And more importantly, we increased a lot the thermal comfort of the occupants. To conclude, I will just give some updates of the current state of development of our product. On the technical point of view, the product is commercialized since 2013. We have different return of experience, and we reach 15 to 40% of energy savings on all the buildings equipped. On the commercial point of view, though, the next step is scaling up. And ProBias is not intended to commercialize itself applications which require such a scaling up in a specific field. We really want to keep a wide view on different sectors and different technologies of artificial intelligence. That's why we are looking for a partner, such as facility management companies or others, to help us in the commercialization of bâtissons. Thank you for your attention. If you have any questions, I will be happy to answer them.
Thank you, Lisa. Actually, we have some questions in the chat. Here is the first. Which kind of big data architecture are you using to collect, enrich, analyze, and visualize data? SaaS platform?
Yes, all the models and computations are on Amazon Cloud. And on site, we have Raspberries and some box to act as the gateway between sensors, radio sensors, and the cloud.
Thank you. Another question. Which type of AI algorithms are used in your solution?
There are different types of AI algorithm, depending on the things we want to learn. But we use Kalman filters for some of the parts, and and that's mainly the one we use in bâtissons.
Thank you. So I see somebody writing, but I'm not sure yet if it's going to be a question or not. Yes. What kind of partners are you looking for? Skills, positioning in the value chain?
We are looking for partners which are more important commercial task force than we have, and which is able to reach the customers and the final client end user better than we can. But we are very open in the discussion, and so if you are interested, don't hesitate to contact me.
Yeah, and again, I re-emphasize that you are able to, I saw, Lisa, you are on the B2B platform, so if somebody wants to meet you starting 12, it's still okay for you to meet online. Okay. So feel free to ask for a B2B meeting with Lisa. We have a last question from Henri about the historical data size.
For the first learning of the building model, we only requires 15 days to up to 1 month. But then we continue to acquire the data at every moment in order to improve it, to continuously learn the models and to integrate the difference of if the building change of evolves on its use. So for some buildings, we have 3 to 4 years of historic data size.
Okay. I see somebody is still writing as well. No, thank you. It was a thank you. Thank you, Lisa. And I now will give the floor to Frank Fischer from Auvergne-Rhône-Alpes to tell us about IoT as an essential brick for energy management. The floor is yours, Frank.
Thank you, Ingrid. So good morning to all. Before introducing our company and vision of smart building and energy management, I would like to thank Minalogic and Tenerrdis for this opportunity to demonstrate the strengths of the economic and technological ecosystem in the Auvergne-Rhône-Alpes region. And I also want to thank you, of course, all the other companies for their great presentations, which gave us many useful information and insights. So first of all, we're going to start by presenting quickly the company. So Auvergne-Rhône-Alpes is a company located in Crolles, near Grenoble. We have been founded in 2000, so we have almost 21 years of existence and experience. Our core business is to design, manufacture, and sell IoT sensors and wireless solutions, especially dedicated to operational performance of building professionals. We are running offers and solutions around IoT protocols such as LoRaWAN, Sigfox, and also we are starting to develop and sell offers around the 5G networks. We are a company, a small company of a little bit more than 30 employees. And we are also a listed company in the Euronext growth market. So, hold on. So maybe some small bullet points around the smart buildings and the state of art. As reminded by Jonathan from Sylphan, the building sectors represent 44% of the energy consumed in France, which is far ahead from the other sectors such as the transport. And each year, the building sector emits more than 123 million of tons of CO2, which make it one of the key areas in the fight against global warming and the energy transition. So that's because they make up the city. The building are its first pillars, and we have to focus on a better management of the buildings. The transition to the resilient smart city requires the development of smart buildings, of course, but they have to be connected by smart networks. So it's therefore necessary to rethink the architecture, the monitoring, and the control of energy, water, heating, and mobility networks in order to turn to more resilient systems. And even at the scale of a building, the use of smart technologies make possible to better control energy consumption as well as equipment maintenance programs. And you will see that through IoT solutions, it is easier to consume the energy that we really need, of course, save on energy bill and improve the energy demand while limiting carbon emission and footprint, especially for existing buildings, which are the worst cases in terms of energy savings and efficiency, energy efficiency. So, as you may know, the big challenge of our century is to decrease the fossil energy use and to increase renewable energies in the framework of the climate constraints. So smart building connected to smart grids can significantly contribute to these objectives. As I told you, the buildings are the biggest consumer of energy in the electrical grid and could be among the greatest producer of renewable energy, especially thanks to the concept of energy positive and by offering at the same time high flexibility in energy demand. And in addition, the European regulatory and normative framework is becoming more and more coercive and requires rapid, effective action with a real return on investment. So I'd like to show you some example of what can be done in a smart building. So our solution allows to optimize the energy performance and maintenance of the buildings while improving the comfort of occupants. If we are talking about the value chain, Adonis is focused on the beginning of the value chain. We are manufacturing sensors. We are running connectivity through public or private networks, and we are ensuring secure and reliable data to our customers and partners, which can be, of course, facility managers, social landlords, property managers, and city managers. We have, as you can see, thousands of use cases deployed with our customers in the building especially, but I have chosen two of these use cases to illustrate what can be done through IoT solutions. So the first use case is the energy consumption monitoring. Our customers, in this case, is the Pas-de-Calais department located in the north of France. The challenge was simple. The Pas-de-Calais department must remotely read the consumption of 165 administrative buildings and colleges under its supervision. It's a project of very big and considerable scale because it represents more than 1 million square meters of surface area to be equipped. So the department wished to regain control of its energy consumption and chose a complete service for this purpose. Data feedback from the real estate portfolio with Adonis sensors, centralization of energy bills, analyzing of energy data. And we had to run this use case with one of our partners, which is Adviseo, which is running a platform of monitoring of the energy. So the solution has been deployed to collect energy data from all the 165 buildings. And it was including, of course, IoT sensors and the main platform from Adviseo. So if we have to focus on the key figures of this development, which is one of the main interests of the IoT solution, is from the deployment of the sensor to operational energy management platform. It took only 2 months to deploy it because it's not intrusive. We don't have to install everything by running existing system. We just have to deploy a very simple system based on the wireless solution. It was mixing public and private networks in this case. And our customers was very focused, of course, on the return on investment. And in this case, it has been reached in less than 1 year by reducing the energy consumption of 17%. And the better prediction of energy consumption, of course, help the customer to anticipate the demand from the energy suppliers. So it was the first very big deployment using the LoRa technology for us, and it has been very successful. And now we are working with the department in other subjects such as air quality and maintenance of the equipment in the building. The second use case I would like to show you is a use case focused on the solar panels monitoring. it has been done with another of our partner, which is Texol, and the objective was to detect in real time a failure with thermal or photovoltaic installation in order to optimize the production of solar energy and then, of course, reduce the amount of consumption. As you may know, whether it's thermal or photovoltaic, solar energy is on the rise. Its use continues to increase over the years. And just to give you an example, the increase of photovoltaic production has been from 11% between 2008 and 2019. And my guess is that it will continue to increase. And today, solar voltaic installation are very often used in addition to conventional energies. Therefore, if a failure occurs with this installation, it cannot be detected since the building is powered by source found elsewhere. So detecting a failure is therefore very essential in order to avoid shutdowns of the installation and of course because it results on financial losses, and our solution has been very simple because together with Texol we have installed in all the solar panel system some sensors, very simple sensors with analog interface, to detect in real time the shutdown of inverters and of the power station, which represents something like 80% of the failures on photovoltaic installations. So when failure is detected, of course, it immediately transmitted, an alert is immediately transmitted to the platform through IoT networks. In this case, we used public networks such as Sigfox. And then the facility managers or the property managers can immediately decide of sending a team on the site to repair and modify the installation. This system has been installed pretty quickly, and today with Texol we have installed sensors, connectivity and data transmission in more than 2,000 photovoltaic installation, 500 thermal installation, and with Texol we are sending more than 60,000 alarms every month, which is used, but you can imagine that by being able to repair very quickly all the installation, the gain in terms of energy saving is just huge. So to conclude, the smart buildings integrated into smart cities are a real key challenge for energy transition, and the IoT will be one part, of course, of this technological help to the transition. Smart buildings have to be thought as a main building, living by itself, but it has to be thought also by being connected to all the other buildings to create a smart city and smart networks. It becomes possible to optimize, of course, all the exchange of energy and data between all the buildings. And today we can anticipate that everything will accelerate because new networks are appearing, such as 5G networks, which will allow real-time connectivity and communication between the buildings. Edge computing and artificial intelligence also will accelerate the predictive energy management and the smart building and city connections. Thank you all for your attention. And of course, if you have any question, I will be very happy to answer.
Thank you, Frank. I don't see any question yet, so if people have questions, please write them down now. Otherwise,
I will be happy to answer later through the chat or through the meetings.
Okay, yeah, somebody is writing. No, it was
it's
a thank you. Thank you.
Thank you to you, Arnaud. Thank you.
Now we've heard a lot about different size of private stakeholders, large companies such as Schneider Electric, smaller ones such as Lancet, Sylphen, Probayes, Adonis. And now I would like to give the floor to a different type of organization, that is to say academic research. And I will leave the floor to Maxime Lefrançois from École des Mines de Saint-Étienne, which is in our Auvergne-Rhône-Alpes region, well known for its soccer team earlier when I was young, and for many other aspects. Thank you, Maxime. The floor is yours.
Thank you very much. Can you hear me well? Okay,
yes.
Very good. So I move on with the presentation. So thanks for the introduction. So my name is Maxime Lefrançois. I'm associate professor at École des Mines de Saint-Étienne, which is part of a big institute called Institut Mines Télécom. So this is a French National Institute for Science and Technology. It's a public institution that federates like engineering and management schools, including IMT Atlantique, IMT Lille Douai, IMT Mines Albi, IMT Mines Alès, Télécom Sud Paris, Institut Mines Télécom Business School, Télécom Paris, and Mines Saint-Étienne, which was the first engineering school outside the main Paris region. It represents approximately 1,400 faculty members and 1,700 PhD students, and we have approximately a fourth of the total contract research income generated in France per year by the more than 200 French schools of engineering. My presentation today will be to present some research projects that we have in the research institute that I belong to, which is one of the 5 research institutes of École des Mines de Saint-Étienne, which is called Institut Fayol. And I will focus on applications on AI. So to put our institute on the global picture here, so Institut Henri Fayol is part of Mines Saint-Étienne. That is also part of Institut Mines Télécom. We have we are a pluridisciplinary institute with 4 teams. So I'm part of the computing and intelligent systems team, but we have also researchers in mathematical and industrial engineering. We have a strong team in environmental and organization engineering, and on another one on responsible management and innovation. So we belong to 3 different CNRS laboratories. So I'm personally part of LEMOS, but we also have researchers part of EVS, Environnement, Ville, Société, and Coactis. We have regional partners, la région Auvergne-Rhône-Alpes, and 3 technology platforms. So recently, DWI was inaugurated. So it means Digital Intelligence Way for Industry Institute. So it belongs to the Auvergne-Rhône-Alpes region, funded by Mines Saint-Étienne, and is located on the digital campus of Charbonnières-les-Bains near Lyon. So it shows on approximately 80 square meter. What is our vision of a small, medium-sized company working on the industry of the future? with its industrial processes and support services. It hosts, for example, the Orange 5G lab, on which we are involved here, our team, on demonstrating our research expertise on the IoT and more specifically the application layers. So we have also two local technology platforms. So first, the territory platform. So what we call technology platforms are labels and a platform where we can make research projects raise their TRL level until the state where they are ready to be to migrate to spin-off or created startups. So this territory platform has one startup recently created that is called URBS, and I will present a solution of this platform in the next slide. So this is territory platform is an innovation platform for, in general, territorial governance solutions. So we are focusing on buildings, logistics, mobility, and environment. And the goal is to support, in general terms, spatio-temporal decision-making in territories. We expose modular and evolutive applications that target heterogeneous domains. And on the environment aspect, we anchor on the United Nations Sustainable Development Goals. So one example of a solution that went through the TRL raising a process is the IMOP solution. So it is built on huge data sets of indicators at the address level, including geolocation, cross-referencing, reconstruction, and reliability of territorial data qualifying the housing stock. So it includes geographic information, cadastre, areas of interest, census of populations and localized income, land and tax files, energy data, and specific data. And the particularity is that the data is either here obtained from these open source or from the partners, or reconstructed using AI techniques. And there is a platform to visualize here the different indicators. So the goal of IMOP is to help the deciders to plan large-scale energy renovation of buildings and housing. We have a pilot that is actually our own building. So we are located here at Espace Foriel in Saint-Étienne. So this is not the historical site of École des Mines de Saint-Étienne, but it is the formerly formerly Manu France building. So the most ancient of among us French people would know about Manu France. What we have in this building, we are starting to, we ambition to make it a candidate pilot smart building for any new collaborative projects that we could be part of in France or in Europe or even regionally. So what we have is a web-based linked, so the linked data building model for this. We have the control of our heating, ventilation, and lighting with, originally Instabus. The installation was from 1994. Instabus was created in 1989, I think. And so now we have KNX net over IP control on that. But we are currently deploying a set of heterogeneous IoT devices. So heterogeneous here is key for us because that's one of our main expertise in the computer science department. And we use heterogeneous IoT technologies, but we also use heterogeneous data formats and heterogeneous data models, and we want to demonstrate how all this can interoperate on the semantic level. We have access to our consumption data, obviously, and we are also working on autonomous robots that can move on the stories and make measurements in different locations, or connect to an isolated Bluetooth device and send messages, for example. The second technology platform that we have here locally is on the ground floor of our building. So it's called ITM Factory, and it is a collaborative space aiming at uniting actors around the issues of industrial transition. So we demonstrate here some technologies that we consider the industry of the future, and we organize formations for SMEs to decide then whether or not they want to move on in this direction in the digitalization of their company. So some examples of collaborative projects that we worked on, and so I give here a very small subset of these projects that we have. Mireille Baton-Hubert from the Applied Mathematics Department will give a focus on another project on April 1st. I think the last edition, the last workshop in this series. I was recruited personally in 2014 after my PhD that was on applied linguistics, on knowledge representation for applied linguistics, on Eureka ITA project called SmartEnergy Aware Systems, which was quite ambitious. So its general goal was to design and develop a global ecosystem of services and smart things, collectively targeting the stability and the efficiency of the smart grid. So this project was led by ENGIE and involved 34 partners in 7 countries for a total budget of 16 million euros and 160 person years. So it ended in 2016 and received the ITA Award of Excellence for Innovation and Business Impact. And there are some follow-up on this project. So in more especially what we were involved in at Mines Saint-Etienne, which is the design of the knowledge model. So I will show that the C is what we call ontologies. So that's a formalization of a shared conceptualization of a domain. Is now progressively being integrated in the smart applications reference ontology of the ETSI, so the European Institute, the European Standard Institute for Information Technology. We are currently involved in ENR project. That's a French national project called Constrained Semantic Web of Things. So here, the focus here is, so we are on top of the IoT. What we are especially interested here is to try to bring the web architecture principles and the web way of developing applications on top of the IoT. So considering not only that we are on top of IP, but also that we try to embrace all the benefits that the web provided in terms of long-running application and separation of concerns. And we believe that so we work also on a specific topic in AI that is called the semantic web, so which is part of symbolic AI, where we aim at making machines capable of using the web like humans do, so navigate and reason with what you can find, and so that's partly called the linked data and partly called reasoning on the web. What we aim here is to adapt those semantic web technologies to constrained device that you can have on the IoT. And we have two application domains. One is smart building, and the other one is sustainable agriculture. So we want to demonstrate that our proposals in work package 1, which is the interoperability, semantic interoperability, and work package 2, which is reasoning, can actually be applied on IoT settings, both in smart building and in smart agriculture. So in smart building, we have our own building here, the Fayol building. That is one of the pilots. And another one, which is located on Lyon Tech Campus Ladoua. In the industry of the future domain, so one example of a project is R&D Booster CIRAM, which means Integrated System for Mobile Assistant Robots. So we have here an automated guided vehicle, which has a robotic arm on top of it. And this robot evolves autonomously in the factory and is able to pick up some goals and some tasks and help the operators to optimize their goals. So here you see here the pyramid of automatization. We are working on optimizing the flexibility and the efficiency of production lines in the industrial environments. So in dynamic settings with heterogeneity of the machines, the protocols, the data. So we use a bit of BatchML from ISA 95, a bit of OPC UA, for example, and some REST, HTTP-based interaction. And so hybrid, so involving nomadic robots and humans. And we will set up multi-agent service-oriented infrastructure here. Following these different, and in parallel with these different collaborative research projects, so one of our strong points is that because we are targeting semantic interoperability and because semantic models gain value with the size of the community that use them, we are strongly involved in standardization efforts on the Internet of Things, in smart networks, and in sensor networks, and on BIM, on the building information model. So one example, one outcome of the SEAS knowledge model design was to contribute to the Southern SSN ontology from the Open Geospatial Consortium and the World Wide Web Consortium. So this is the fact of the standard ontology for representing sensors and actuators on the web and the observations of or actuations that they make. We are also very much involved in the development of the Smart Applications Reference Ontology at ETSI, which is the European Telecommunications Standard Institute. So SAREF is the European shared model of consensus to facilitate the matching of existing assets in the smart application domain. So it is based on patterns that are under construction, and then you have SAREF core and then extensions for different verticals. So some extensions exist for the energy, the environment, building, smart city, manufacturing, agriculture, automotive, e-health and aging well, wearables, water management. We are currently working on an extension for smart lifts. So in SAREF, we contribute to the development of the knowledge model development framework and workflow and the documentation portal. So even if we researchers don't have the expertise in all these domains, we demonstrate how contributions can be taken from the ones that know the domain and automatically generate a high quality knowledge model that is also automatically published. The documentation is automatically published. In the DB3C, I was also co-chairing until recently community group that is called the Linked Building Data Community Group, and one of the production is an ontology that is called the Building Topology Ontology, or BOT, which is a simple ontology for leveraging the web principles in building information models. So the idea is that with the ISC, which is the standard data model for the building information models, you would want to integrate as well the architect model, but also the engineering model and the actual building data and the operations model, like the actual sensor measurements that you can have, and all this actually on the web in a way that is compatible with the BIM, so level 3 actually. There is so we recently recruited a new associate professor called Victor Charpenay, who was very much involved in the development in the working group on the Web of Things at the W3C, which developed a set of standards for solving the interoperability issues of different Internet of Things platforms and application domains. So one of the key production here is the thing description model for smart things, where in a nutshell, a thing that is deployed on the web, no matter what communication protocol it uses, would expose properties, actions, and events that you can subscribe to. And the thing description aims at enabling you to discover things and interact and knowing automatically how to interact with them. So we are interested here on the merging the multi-agent domain and autonomous agents on the web with the IoT using semantic web technology. So I will conclude here. So I aim to introduce the Institut Fayol at Mines Saint-Etienne, which is a pluridisciplinary and complementary research institute. So I gave a focus on AI research. So we have technology platforms at hand and a smart building pilot. We have experience in applying our research in different verticals, including the smart grids, the smart buildings, smart territory. And we are also contributing at the same time to international standard development organization in semantic interoperability for the IoT. So thank you very much. I'm looking forward to answer any question that you may have.
Yeah, thank you, Maxime. Indeed, we have a question for you. So we will display it. What makes energy BIM different, more challenging compared to the other sectors such as automotive, water, or can we simply build further on the work on algorithms and ontology done in the other sectors?
So we can build on what has been done in other sectors, right? But what makes the energy and the BIM different or more challenging is that it actually forces to break the silos. As you can consider that, well, there are standards in the smart grid domain. There are standards in the building domain. And now you want to manage the energy in the building. So you'll ask yourself, okay, what standard I want to use, or what technology I want to use, what communication technology I want to use. So knowing that we will use the internet and that we will build on top of the IP is a first step, because we are all working on the same transport, layer level. But now what is challenging is to have those different, information models and that are compliant with different standards for different verticals work well all together and interoperate on the semantic level. So actually, I would add on top of this question that it's not even that's simplistic. So if you consider that in the automotive industry, we are switching to a model where cars are now electric and can actually connect to electric vehicle service equipment that are connected to the smart grid. So you could consider that electric vehicles that have a battery can actually provide a service of voltage regulation. And so you have also to break the silo between the automotive sector and the smart grid sector. And potentially the automotive industry can become a player in the smart grid domain.
Yeah, for sure. That's the vehicle to grid topic. And we couldn't cover it all today, but thank you again, Maxime. Thank you to all the participants. We will now have a short, very short survey for you to evaluate if we met your needs and your expectation during this webinar. So I leave it to you to answer the survey. And then I will shortly introduce to you the next sessions of webinars of next week, the week after. And then it will be room for the B2B sessions. Please use this opportunity. Thank you for your votes as well before leaving.
Good.
Who's talking, Maxime?
Yes.
Okay.
I'm
yeah,
an
you need
animator.
Yeah.
Okay. Thank you, animator.
We leave the survey open. It's we are gradually rising to half of the participants have answered the survey so far. As a reminder, these webinars are being recorded, and we need, of course, all the speakers' authorization before putting the videos online, and we will do so at the end of the 6 webinars. So you will be informed when this will be available. Feel free to ask your question in the chat for us, for if you need any more information. I guess I don't see any new vote. I think we can leave it here for the survey. And it's time for me just to show you that we are almost halfway through our webinar series about smart grids. And next week, we will talk about storage. The week after, we will talk about trends and innovative projects. So we will look at what are the major projects, smart grid projects in France. And the last session on the 8th of April will be to meet smart grid innovators. So very short 5-minute presentation by tens of, not tens, but 10 innovative companies from our region, both in the energy sector and in the digital sector. So this is all detailed here. The program for next week about storage, the program for the week after about trends and innovative projects with our colleagues from the Cap-Énergie cluster and some projects from western part of France as well. And again, the week after, this presentation by innovative companies, and also connections to Belgium and Italy with our colleagues from our participating clusters who will shortly present what they do with regard to smart grids in their own regions. So we've done the, yeah, oops, sorry, I was fast. Now it's time for you to get ready for the matchmaking session. Again, take this opportunity. It's free of charge. It's included because it's part of a European project. You can just register using the link which appears here on the screen, and it's up to you to decide with whom you want to meet for 15-minute short B2B meetings. Thank you all for your participation, and see you next week. Bye-bye.